We're talking about permutation groups, and I'd like to now introduce you to a new concept, very important in the context of permutation groups, and that is the notion that all permutations are of two broad types, two categories, two families. And one family is known as odd, so a permutation, a member of the permutation group is either odd or even. And there are an equal number of odd permutations as there are even permutations, although I'll talk a bit about that quite a bit later. So usually, odd and even, they refer to integers. So in what sense is a permutation? What connection does that have with some integer, some measure, so that you can talk about a particular permutation being odd or even? So to introduce that, I need to go through a bit of theory, and I'll explain. Well, here's the sort of conclusion. But I need to explain to you what a reversed pair means. And then once you're familiar with this concept, and we'll do it in quite a bit of detail, by the time we've finished all this stuff, you'll have a pretty good idea of what a reversed pair means. But here's the new term: a reversed pair. A pair of what? And in what sense reversed? Okay, so let's start. You take any permutation. Let's say we're talking about the permutation group S5, the symmetric group S5. Okay, same thing. So we have 5 objects that we're permuting, and this is one of them. This would be, now let's see how many. So 5 factorial, what's that, 120? So you have 120 elements in this group, and this is just one of them. Okay. Now, from this permutation or permuter, which switches 1 into 3 and 2 into 5 and so on, 5 into 4. Okay, you can associate a number, an integer called n, so a number that corresponds to this permutation or permuter, and it's the number of these pairs where the two integers in these pairs obey this property. Now that sounds very vague. Let me actually give you some examples, and then you can you'll get a better feel for what's going on. All right. So these integers I and j, this pair that you're talking about, these two integers come from the top row of your permutation. Okay. And they satisfy, well, 2 conditions. One is that the number here is not less or equal, just strictly less than the second one. So this has to be less than that one. Now, I and j come from this row, your upper row of your permutation. So can you see that there will be 10 such pairs? Like, for example, 1 and 2 is okay, 1 and 3, 1 and 4, 1 and 5. This is true for all those. This is 1. And then 2, 3 is a pair, 2, 4, 2, 5 is a pair, and then 3, 4, 3, 5, and 4, 5. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possibilities, 10 pairs. Okay? I say again, these two numbers are taken from this upper row. Okay? Your first number here has to be less than your second number here. Okay? So I've written them all out, ready to start doing some work. Okay, now the second condition is for this pair to belong to this set of n. you talk about a reversal. Now, before I explain what a reversal is, switching in a sense, let me put in the values here, like this ij, 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 and so on. Okay. Now here I'm going to put x of I and x of j. In other words, I apply this permutation or permuter to these integers. So x of 1, if I is 1, so x of 1 give me 3. Okay? So let me just fill these values in. So here I'll put x of 2 and x of 5. Here I'll put x of 2 and x of 4, and so on. So let me fill these in. So x of 1. So I apply the permutation to 1 of x to 1. I'll get 3. So wherever I got 1, I can put 3 here. Okay, 3, 3, 3. Right. And now x of 2, well, 2 maps to 5. So my x of 2 will be a 5 here. Any more 2s? A 5, 5, 5. Right. Now 3, x of 3. X of 3 gives me 2. So wherever there's a 3 here, I put a 2 here. 2. 2, 2. Right. Okay, next one. A 4. So x of 4 will go to map to 1. So wherever I've got a 4 here, I'll put a 1 under it. So 4, 1, 1, 1. Okay. And now 5. So I'll put x of 5 here. So 5 maps under x, 5 maps to 4. So I put a 4 here. 4, 4, 4. All right. Now, all right. Now, what do I mean by a reversal? Well, you get a reversal. Now, I is always less than x, right? But when you take the permutation, x, and you apply it to I, if the result is larger than what you get for x of j, you've got a reversal of the order, right? Here, I is less than j. But if x of I is greater than x of j, then you've reversed the order. So x of I is now larger than x of j. Here's I is less than j. So each time you get this one bigger than that one, you've got yourself a reversal. And then for all pairs, all 10 of them, for this case, you form the set of the pairs ij where you get this reversal of the order, where x of I is larger than x of j. So let's look at these 10, and I'll put a dot, I guess, a big dot, at the cases where x of I is larger than x of j. Now, how about here? Is xi, that's xi, is it greater than xj? No. So do nothing. How about here? Yeah, that is bigger. 3 is bigger than 2. Alright? So I'll put a dot there. 3 is bigger than 1. Put a dot there. 3 not bigger than 4. 5 bigger than 2? Yes. Okay? 5 bigger than 1? Yes. 5 bigger than 4? Yes. 2 bigger than 1? Yes. 2 bigger than 4? No. 1 bigger than 4? No. Alright? So perhaps I could put it this way. So this is your set of the pairs that satisfy these two properties. Okay? So it's the set of reversed pairs. Okay? Now the size of it is what? Well, you just count up the number of pairs. 1, 2, 3, 4, 5, 6. Okay? So the size of your n is, why don't I just do it this way? Just define it like that. And get rid of this. Okay? So n then is just the size of the set.